Hi, Amanda. I guess I am not a chew toy.
Hello. Let's see how to do that here. My name is Amanda Olson, and I'm going to be teaching this workshop. It's called Teaching Math Through Nature. Um, hey, before I get started, I'm also a professor for Los Angeles Pierce College, and I also run a early education program for children from infancy through 5 years old, and we also have an enrichment program for school-age children. Before I get started, does anybody have any questions? So let me just start with, oftentimes for those of us in early education, the concept of teaching math can be overwhelming because we think of math in adult terms, and many of us struggled with math, some of us not, but some of us did, and we often are not very confident, and we go to teaching math that is more geared towards older children, and not thinking about as much of what math looks like in early education. So let's first talk about the concepts. Let me go ahead and pull up the, um, the screen, and then I will, let me share with you. Let's first talk about what are some of it. Before we start talking about using nature to teach math, let's first start by talking about what math is appropriate to teach during the preschool year. And let's start with that. All right. Uh, All right. So these are some math concepts that are appropriate. If you look at the frameworks and the California state standards, these are some of the concepts that they want or expect children to kind of start to understand from, you know, 3 years old to 5 is the concept of shapes, sorting, patterns, one-on-one correlation. One-on-one correlation is much more important than sometimes we focus kind of more on counting, which is very abstract and doesn't have a lot of meaning to them. But if you think about one-on-one correlation, that means one leaf, on the letter one, two leaves, and they look at the numbers and what is one, how many is two, how many is three, and that's one-to-one correlation. right? Which is very important. Classification, right? So classification can be a lot of different things. It's similar to sorting, but what is a natural item versus what is plastic? When we do activities like sink and float, you're classifying what sinks, what floated, right? That's classification. That's a math concept. It's also a science concept. Some of these concepts are very intertwined with science. Size, small, medium, large, little, tall, big. Those are all math concepts. Spatial relationships. What is smaller? What is bigger? What is wider? Um, those are all math concepts. Measurements. Blocks are very mathematical, support math in a lot of ways. And we give things, and we can do that in nature too, like, scales for them to weigh things, measuring tapes, rulers to measure how big something is, how wide something is, and numbers, but also trying to put a meaning to those numbers. So what does 1 mean? What does 5 mean? Right? And that's why we want to think about teaching math um, in very concrete ways. And we'll talk about that a little bit more. Nature and hands-on learning. By integrating math concepts onto outdoor exploration and play, preschoolers can develop a deeper understanding of mathematical concepts while connecting with the natural world around them. Right? This hands-on and experiential approach to learning fosters curiosity, creativity, and a love of math from an early stage. So when we say that they get a deeper understanding of these concepts because they're experiencing them in an experiential way or an experimental way, I would say either way. It's because, for example, if I'm planting seeds or a garden, right, I want to put 3 seeds in every single hole, right? If it's a garden, or 3 seeds in the cup or the pot. That is counting things, but it's one-on-one correlation. So they're understanding what 3 means, not just that it's this shape that, with 2 bumps, right? But that 3 means something and it's concrete and they care about it. And we know that John Dewey, who came up with the philosophy that knowledge was relevant, that it had to be relevant in our lives to remember it, has now been proven because we know that the part of the brain that stimulates long-term memory is stimulated by emotion. So when children care about what they're doing, they feel connected to what they're doing, they're more likely to remember it. So children love to plant seeds and they will remember what 3 means or 4 or whatever it is that you're using, right? And that's an important thing to think about when we think about using nature in this way. All right, math should begin with natural and informal situations. So rather than taking, math out of the natural world or informal situations, like we're all going to have snack now. How many children are here? So how many cups do we need? Right, that's an informal situation in using math. But we can use nature in that way as well, right? I see 2 birds in a tree. How many birds do you see? Right, so all of a sudden counting, rather than just counting with no meaning behind it, all of a sudden counting has a relevant meaning, right? We need to wait 7 days after planting seeds to see them sprout. All right, all of a sudden it has a meaning, whereas Monday, Tuesday, Wednesday doesn't have a meaning. But 7 days has a meaning when we count them. Oh, today's day 2, today's day 3, today's day 4, because it has a meaning in their life. It's relevant. How many slices of apple would you like? Again, using everyday experiences to incorporate math concepts. This is much more important than having them circle something on a ditto form, right? That has no meaning necessarily. For the chicken coop, we have chickens at our program, had 3 eggs today. So these are pattern blocks that a lot of us use. These were attached, right? So And this is forming what's called a tessellation, which is a mathematical concept. So tessellation is a geometric concept that involves covering a surface with a repeated pattern of geometric shapes called tiles without any overlaps or gaps. All right, that's when we make one. That's what this is. This is tiles. Doesn't have to be tiles, but in this case it is. And it's a geometric concept. So for those of us that took geometry and remember, we learned about tessellation. But interestingly enough, tessellations exist in nature all around us, right? So this is a dragonfly wing. And if you look at the shapes inside, so we can use microscopes, we can use photographs and show children how shapes exist in nature, right? And this has a great, this is picture, I think you would agree with me, is much more interesting than this one, right? So children are fascinated. We don't even have to get in, and when you look at the dragonfly's body, how there's even patterns there. But if you look at the wing, you see all these shapes connected, and they not only are shapes, because we see hexagons, right? We see elongated rectangles, but they're connected, and they're forming a tessellation. Here's another example of tessellations in nature. One is the giraffe. The other one is the turtle. And so when you show books, because there's books that have these pictures, but sometimes we just download these pictures and we print them out and we make our own books. And we just, or you can make a board. And children find this very fascinating. And then what will happen is they will start noticing these patterns themselves in nature because they really exist all around them. Right, here's another one, a honeycomb is technically a tessellation. And a lot of flowers grow in a way that they are considered a tessellation. And also you can see patterns just in general. And patterns are very mathematical, right? So when we try to show children how to use beads or other items to create patterns in our learning plans, right? This creates a great foundation for understanding what a pattern is and how it repeats itself. So let's talk a little bit more about patterns. Even spider webs have patterns. When we are outside with children, we almost always can find spider webs, and we clearly, wipe them off. But we might want to take some time, especially because most of them, the spider has abandoned it, to get a magnifying glass and show them the patterns in the spider web and how intricate they're made. See, these are things that children really love and find interesting. They're very relevant, so they remember them. Butterflies, if you look at they're completely symmetrical. One side of their wing completely matches the other side of their wing. And again, patterns, right? And also variety within those patterns. Spirals. So another thing that really exists in nature is spirals. So one thing that you can think about, and children find this very interesting, is that even animals sleep in a spiral because a spiral shape protects them. If you think of us, if we're trying to get to a place of safety, we usually curl up, right? That's kind of trying to make a spiral. But throughout nature, spirals just exist. And it's a different kind of pattern. So you can see that there's tessellations, there's patterns, and there's spirals. But even within those three, look at the spiral here on the inside of the shell. There's a tessellation, there's also a pattern. So showing this to children, counting them, right? Which ones are smaller? Which ones are larger? You notice that within the middle of the spiral is the smallest. And then as they move out, the sections get bigger. And we talked about the concept of sizes. What is smaller? What is bigger? Right? In things and in areas that children tend to find very interesting. Children love science. and science is very connected to math. Again, so when we grow things, this is the inside of the flower, right? And we can see the pattern, we can see the spiral. And this is another example of a snail and the spiral within the shell. So these are all things that we can look at when we have nature walks. We can grow these things in our environment. We can bring them into our environment and all use them to support um, math concepts. This is a great activity that you can do with children. We do this many times, and you just get clay, just plain old clay. You can get air dry clay, and we have them, we cut out different shapes so they can make different shapes, and then they can create patterns. Now, in this case, this is just simple black beans, pinto beans, and some lentils. But you could use little rocks. You could use all kinds of things that you would collect. But allowing children to then mimic and copy the pattern. And again, you think about what, for those of you that, feel free to chime in, what concepts do you see mathematically that children are learning through just this activity that you see on the screen? Anybody want to? I can't see the chat, so you'll have to speak up. Well, we talked about sorting, right? So the items that they're making them with are sorted, right? The beans and the lentils, and we don't see the black beans, but they're there. They're not just thrown on the table. They're sorted into separate bowls. So sorting in this activity is a mathematical concept. They're also, through what they're making, is also showing patterns, right? And they're creating a pattern in what they're making. You can see that in just how this butterfly has its wings, how the snail has the spiral, right? So this is just a very simple, fun activity, but you can see a lot of math through this. And this is a lot more interesting and engaging than, for example, just having some, a sheet that would have them circle something or draw it, right? This is hands-on, three-dimensional, and has a lot of learning opportunities. Using rocks in your environment to build spirals. Again, the rocks are going from large all the way to small, and the very smallest in the middle, right? And so obviously these rocks have been sorted ahead of time. You can do this, you don't even have to do this on this big of a scale. This is at a forest school. Not all of us or not all of you have that ability. You can do this on a small scale at a table. I even have blocks now that look like rocks that are made out of wood. But you could take rocks, collect rocks, sort them, biggest ones to smaller ones, on a nature walk. Here you can see they painted them and then they sorted them to make the spiral to show how the smallest rock is on the inside of the spiral, whereas the bigger rocks are on the outside. And again, it's sorting, it's correlation, it's size, comparison, it's all of those things that teach these mathematical concepts. Nature math activities. So nature walk counting. Take preschoolers on a nature walk and encourage them to count objects they see along the way, such as flowers, trees, rocks, or birds. They can keep track of their count by marking tally marks on a clipboard or collecting items in a nature counting basket. You can also take something, you can just on your walk, you can take an egg crate with the 12 different, containers or areas that hold an egg. And in each area, they can classify and sort them into that hole, those separate little holes, or in, things where the eggs go. Nature sorting and classifying provide a variety of natural objects such as leaves, sticks, stones, and flowers, and ask preschoolers to sort and classify them based on different attributes such as size, shape, color, or texture. You can even do that with leaves. You can collect a lot of leaves and sort them by color and also by age. Which leaves seem new? Which leaves are dry that have been off the tree longer, right? They can sort leaves by color, group rocks by size, or classify flowers by shape. Nature measurement. Use natural materials such as sticks, leaves, or stones as non-standard units of measurement to explore length, height, weight, and volume. Preschoolers can measure the length of a log using sticks, compare the weight of different rocks, or estimate the volume of a container filled with water. Nature patterns. Explore patterns in nature by identifying and creating repeating patterns using nature objects such as leaves, flowers, or shells. Again, like what we talked about, just creating patterns with natural objects. Preschoolers can create simple A, B patterns, right? Leaf, rock, flower, leaf, like that. Alternating colors or shapes, such as blue flower, pink flower, blue flower, pink flower. You could do it that way too. Or more complex pattern using multiple elements found in nature. Gardening and math. So gardening really has everything in it. Gardening has science because they have to learn about what grows in different seasons, what makes something grow. Vegetables need at least 6 hours of sun a day in order to grow. If you plant a vegetable garden, they learn about water, that plants need water. If you introduce worms into the soil, which is a good idea with a garden, you can have a whole activity or unit around worms, earthworms. But they also learn responsibility with gardening because gardening, too many times in our activities, it's kind of like a one-shot deal, right? We have one activity, we do it that day, and then we're done. But gardening and other activities like that have more longevity, that are more of a project-based approach, they teach responsibility because if you don't feed that garden, if you don't water it, it's not going to grow. If you don't take care of it, it's not going to grow, right? And you have to harvest once they are mature or as they get mature. And so it has a lot of learning benefits. This garden doesn't show this, but in a lot of our gardens, we label what they're growing. They write signs, beans, tomatoes, and then put them where that is growing. And it's also literacy and language in a way that is relevant to something they care about. But it's also very mathematical because when you plant a garden, you keep track of, typically when you plant a seed, it takes about 7 days for it to sprout. When you plant a particular plant, you usually know how long it's going to take to mature. So when we plant pumpkins, we know they will take at least 90 days, 3 months. So we talk with children about that. We plant them in the beginning of summer and they will be ready to pick usually by the beginning of fall, right? And so that has a relevant sense of time that they look for. Eggs, right here, when children collect eggs, they're able to count them. They're also sorted. How many brown, how many white eggs in this kind of environment. Math concepts learned through gardening, counting. Gardening offers countless opportunities for counting, from counting seeds as they are planted to counting the number of plants or flowers in the garden. Children can practice counting seeds, plants, flowers, leaves, or fruits as they observe and care for their garden. Measurement. Gardening involves measuring and comparing different aspects of plants and garden features. Children can measure the height of plants using rulers or measuring tapes. We even, last summer, we made a graph. We planted corn, and we actually made a graph. And every week, the kids decorated it, and we hung it on the wall. And every week we measured the corn and we put it on the graph. So they were able to see over time how much the corn was growing and how quickly it was growing, which is a mathematical concept. Children can measure the height of plants using rulers and measuring tapes, estimate the length of rows or garden beds, and compare the sizes of leaves, flowers, or fruits. Math concepts, more concepts. It's endless with gardening, really. Gardening provides opportunities for children to practice estimation and prediction skills. That is both math and science. What's going to happen if we put if we plant 3 seeds together? What's going to happen if we plant 2, right? How long do you think it's going to take before this zucchini is 6 inches long? Just like I said about the corn when we made the graph, right? If it's growing this much every week, how long is it going to take before it's this tall, right? They can estimate the number of seeds needed to fill a planting row, predict how tall a plant will grow, or estimate the amount of water needed to water the garden. Through observation and experimentation, children learn to make informed guesses and refine their estimates over time. Geometry. Gardens provide opportunities for exploring basic geometric shapes such as circles, plant pots, squares, garden beds, triangles, and rectangles. Also garden plots. Children can identify and describe the shapes of various garden elements and create geometric patterns or designs using plants and garden materials. All right. And many of us don't work in environments. Many of us don't work in environments. It is, somebody just asked me if this is being recorded. It is being recorded. So a lot of us don't work in environments where we have a big garden or we have a chicken coop. Some of us just don't have that available to us. But there's a great book called Bringing the Outside In, which talks about how to bring these elements into the classroom, such as plants and things like that. But you also can grow plants even outside. It's very easy to just find old pots or old milk jugs and plant seeds and at least bring some of this element into your environment. Any questions about any of that? If you do, you can either just speak up, or you can just or put it in the chat. All right, I'm going to play a video that just has to do with the outdoors and the importance of children being outside and just all the learning that occurs through being outside. Let me go ahead and share that with you.
Suppose we are nature, and that drawing closer to nature is not so much an outer journey to some distant exotica, but a journey in the exact opposite direction, inward, to an awakening of what is already contained within. Nature deficit disorder is a disorder of society because it shapes adults, families, whole communities, and the future of our stewardship of nature. If nature experiences continue to fade from the current generation of young people and the next, and the ones to follow, where will future stewards of the earth come from?
And TV and all that kind of things in the past, then they wouldn't have had those. She gone outside and you would just play with sticks, I guess, and played capture the flag in the forest, things like that. Nature outside is the best habitat for a learning community. Sometimes when you're learning, like a breath of fresh air, or take a break and reset your brain so that it's easier to learn again. helps me like connect and just it's a time to be yourself. There's not like going to be a desk to sit at. You're going to have to figure out how to do it in new ways. It's just a time to sort of be free and just open. It's an adventure.
The more clearly we can focus our attention on the wonders and realities of the universe about us, the less taste we shall have for destruction.
We bought it at the farmer's market. Looks like a flower. That's what I was gonna say.
Yeah, she thinks that this artist was thinking of a flower inspired by that. That's what we did this when we were up in Colorland. I think you helped her collect some of the grass.
Yeah.
But I want you to think about what your composition is going to look like. Is it going to have different shapes to it? Is it going to end up reminding you of being inspired by something else? That's the way to do it.
The background.
But you wanted to talk to the background and inspire it. So we didn't like or something, and you can tell me what you think.
A child's world is fresh and new and beautiful, full of wonder and excitement. It is our misfortune that for most of us, that clear-eyed vision, that true instinct for what is beautiful and awe-inspiring, is dimmed and even lost before we reach adulthood. If I had influence with the good fairy who's supposed to preside over the christening of all children, I should ask that her gift to each child in the world be a sense of wonder so indestructible that it would last throughout life, as an unfailing antidote against the boredom and disenchantment of later year, the alienation from the sources of our strength. Contact with nature allows children to see they are part of a larger world that includes them.
Cool earth nurtures the trees, sacrificed for us, for paper. A river of thoughts flows on the earth, with seeds carried out by the wind or carefully plucked out by hand. And they are planted, grow with words flooding from the pen to the paper. They grow from seed to spout, spout to stalk, stalk to bud, bud to story.
As children begin their forays into the natural world, we can encourage feelings for the creatures living there. Early childhood is characterized by a lack of differentiation between the self and the other. Children feel implicitly drawn to baby animals. A child feels pain when someone else scrapes her knee. Rather than force separateness, we want to cultivate that sense of connectedness so that it can become the emotional foundation for the more abstract ecological concept that everything is connected to everything else.
Celebration really was a favorite tree, and we took care of that tree. We said hi to it whenever we passed it. We made sure it was okay. But then one day we came to visit, and the tree was gone. We were sad. We were confused, and we didn't know. So we thought, should we stop our celebration? We don't want to stop our celebration. The tree.
He was protecting us. He was taller than us. His bark was a pretty light color.
And then we have some special messages that some friends wrote, and we are going to plant them in this area. We have a shovel, so if you want to help with that, you can go ahead and help.
It would help. He was part of the arboretum. He was there to greet us. Still able to greet him. And it said hello back. He used to play with us. I liked his leaves. They were mountainy like mountains, connected to make one big leaf. It would fly like a lot of us. We loved it. And a beautiful pink lily. The 12 good things about our tree. We love the tree. He used to play with us.
The world is full of marvels for the eyes to see and ears to hear. Active intelligence will flourish only when we have known the romance of fresh subject.
Let's go make friends with Dada.
If we want children to flourish, to become truly empowered, then let us allow them to love the earth before we ask them to save it. Perhaps this is what Thoreau had in mind when he said, "The more slowly trees grow at first, the sounder they are at the core." And I think the same is true of human beings.
And then let's pack this down, and then we'll put some of this dirt on the top. Maybe the digger right over here. Yeah.
Okay, so that video shows just good examples of how children kind of come alive when they're outside. And when we think about brain development, how much that gives us an opportunity to teach a lot of things, language as well as math. Because language, because of course they have things to talk about and eventually things to write about. And also for math, because when you think about when you see them building outside and constructing outside, they're having to decide how many twigs they're going to use, how much, string they're going to use to tie things together. And so that all contributes to an understanding of math in a very relevant way. Any, I see somebody's asking about it being recorded. It is being recorded. I don't know how they make it available. You'll have to ask the conference. Any other questions or comments? You can put them in the chat or you can speak up. Right? All right, so that's, there aren't any questions. And I'm going to conclude the workshop. Have a great conference.